This question has multiple parts. We'll start by drawing the structures for ethane and carbon dioxide. I'm not going to walk you through the steps on this one, but I am going to show you the structures. And here are the correct Lewis dot diagrams for both molecules. Now to predict the molecular geometry. Starting with the ethane, the C2H4. Each carbon has 3 electron domains. 3 electron domains is trigonal planar electron domain geometry. Each carbon has 3 bonding domains. As a rule, if the number of bonding domains equals the number of electron domains, the molecular geometry equals the electron domain geometry. So therefore, the molecular geometry around each carbon is trigonal planar. For the carbon dioxide, the carbon has 2 electron domains. That is linear electron domain geometry. There are 2 bonding domains, and once again, when the bonding domain number is the same as the electron domain number, the molecular and the electron domain geometry are the same, so the molecular geometry around the carbon in CO2 is linear. When ethane is combusted in excess of oxygen and produces carbon dioxide and water, does the hybridization of the carbon atoms change? And then explain your answer. The correct answer is yes. The hybridization of the carbon atoms change. The explanation: from A, it is known that both carbons in the ethane have 3 electron domains. 3 electron domains means sp2 hybridization. Also from A, it is known that the carbon in carbon dioxide has 2 electron domains, which means it has a hybridization of sp. Since sp2 is not the same as sp, then yes, the hybridization has changed. QED. Then you are given this molecule and you're asked several questions about bond angles, etc. So we start with the first. Determine the hybridization of the carbon atoms that are labeled 1 through 5. C1 has 4 electron domains, so it is sp3. C2 and C3 both have 3 electron domains, so it is sp2. And C4 and C5 have 2 electron domains, so their hybridization is sp. Next, you're asked to determine the bond angles at A1, A2, and A3. A1 has a hybridization of sp3 and no non-bonded pairs, so it's got tetrahedral geometry and 109.5 degrees for the angle. A2 has a hybridization of sp squared. It has no non-bonded pairs. It's trigonal planar geometry, and that's 120 degrees. And lastly, A3 has a hybridization of sp. That gives linear geometry, which is 180 degrees. And the final question asks you to determine the number of sigma and pi bonds in the entire molecule. Now remember, single bonds have 1 sigma bond, a double bond has a sigma and a pi bond, and a triple bond has 1 sigma and 2 pi bonds. So looking at this molecule, we see there are 8 single bonds. So that's 8 sigma bonds. There is 1 double bond, which is another sigma bond and a pi bond. And there is 1 triple bond, so we have 1 more sigma bond and 2 pi bonds. And when you add up the numbers, you get a total of 10 sigma and 3 pi bonds.